Hi, now let's look at the division algorithm by the statement. Given positive integers a and b, there exists unique pair of whole numbers q and r satisfying a equal to b plus r, and there is a condition to 0 less than or equal to r less than b. We just know we have seen the division when we do the division, so for the sake of simplicity I'll write it here. So we divided with 3 to 6 and 11, 3, 9, 2. So we always got the solution like, okay, this is the remainder r and this is the divider, so that is 3. So r is always less than 3 and r is always greater than or equal to 0. That's the thing here. So if you do it in other way, 1, 3, it's become 41, and if you do 2, 6, 35. Here remainder is greater than this one, so it is not satisfying condition this one. So he wanted us to do it like this. That is the reason he wrote this condition. If we hide this condition, we can write it like this and we get multiple solutions. We get what is q and r pair here. Here q and r pair is nothing but 3, 35. This is a pair satisfying what? Here a equal to 71, b is 3, (12) plus 35. So here it is satisfying this condition. This is good. But where exactly it is failing? It is failing to satisfy this condition. The remainder is greater than 3. Here he wanted us to remainder should always be less than b. That is the intent here. So this is not what he is talking about. So in order to make this condition, there will be only one pair. What is the q and r? It is always 23 and remainder is 2. Sorry, here I wrote wrong. Q and R. Quotient is 12 and remainder is 35. We can write multiple pairs. So I showed you in the previous video, like if I put different numbers, then we get different pairs. But that won't be satisfying this condition. In order to satisfy this condition, it has to be 23 and 2. There is no other pair which satisfies this condition with this rule. That is the thing. So I'll highlight few things. Unique pair of q and r, and it has to be whole numbers. Remember this point. Whole numbers means it will be 0, 1, 2, 3, that numbers. So somebody says, okay, I will put 2 by 3 and people are smart. That's the reason they put all these conditions over here. Whole numbers only and q and r, unique pair. So all this like, okay, and given numbers are positive integers only. Positive integers. If you try different combinations, it may go wrong. But the algorithm says if a and b are positive, then we get unique pair of q and r satisfying this condition with this one. So there are so many conditions like, okay, it is just like giving a bus pass to girls, something like that, at a discounted price. In some states they give that one. If you look at that one, they put all the conditions. You have to be a girl, you must be studying, and you must be less than, what to say, less than 10th class, like first to 10th class only, and you can't be more than 30 age. So they put all these conditions. If you satisfy all those conditions, you get a bus pass or anything for a discounted price. It is also the same thing. In order to satisfy this condition with unique pair, unique means one and only one pair, it has to be A and B are positive integers. Then it has to satisfy remainder must be this one. Then only there will be a unique pair. Otherwise there will be multiple pairs. So that is the thing. There are some certain conditions he put. If all the conditions are satisfied, then for this equation there is only one pair for anything. Take anything. Let's take other divisions. Some other division. Let's take 95 divided by let's take 6. 6 ones are 6. 35. If I have to put 5, it becomes 30. 5 is always less than B. Good job. And only one way I can express Q and R as 15, 5 to satisfy A equal to BQ plus R. A is 95, B is 6, Q is 15 plus 5. There is only 15 and 5, only one combination. If I put any other number, this will be increased, or if I satisfy in some other way, so remainder